Lesson 4.3, Proportional Relationships and Graphs. How do you know whether a relationship is proportional just by looking at its graph? Well, two things must be true. You must have a constant of proportionality, or a K, and you also must have the line, the straight line passing through the origin, which is the point 0, 0. It's where the x and the y axis intersect. Now, just to be clear here, just because you have a K, just because you have a constant of proportionality, does not mean the relationship is proportional. You do need a K, but you also need to have the line passing through the origin for the relationship to be proportional. And if it is proportional, remember, we can write the equation in the form y equals kx, where k is the constant of proportionality. Now, how would you figure out what the k is? How do you know what k is? Well, to solve this equation for k, we could divide both sides by x, right? So that x over x simplifies, and we get k, the constant of proportionality, is equal to the ratio of y over x, right? So we could say k is equal to y over x. K is the ratio of y to x. Now, by looking at a graph, we could tell whether it's proportional or not proportional based on, does it go through the origin. So if you had a graph that looks like this, where of course this is the x-axis and this is the y-axis, and they intersect at this point 0, 0, which is called the origin. And so if we're assuming this line is a straight line with a constant of proportionality, you can see it goes through the origin. So it meets the two criteria. It has a constant of proportionality, it has a k, we're assuming that. And then number two, the line passes through the origin. So we would say this graph is proportional. Now here's an example of a graph that is not proportional, right? If we assume that it has a k, a constant of proportionality, it meets the first criteria, but it does not meet the second criteria. This line does not pass through the origin. Here's the origin. This line, if it were to continue, would not pass through the origin. And if it does not go through the origin, it cannot be proportional. So we would say not proportional. Let's look at two examples. Here's our first example. Okay, we are comparing here the age, which is in years, to the tree height. Okay, and we want to know, is this relationship proportional? Well, right away, just by looking at it, you can already tell it does not meet the second criteria. The line does not pass through the origin. If you connect these points that were given to you with a straight line, the line, if here's the origin, the line does not pass through the origin. And so we would say this is not proportional. It is not proportional. Why? Well, it's not proportional because the line does not pass through the origin, and you must pass through the origin for the relationship to be proportional. Second example. Here's our second example. We are comparing the time in hours to the distance in miles. So these points that are given to us, if we connect them with a straight line, which looks something like that, you can see that yes, it does go through the origin. And if it goes through the origin, it can potentially be proportional if it has a constant of proportionality. So how are we going to check that? Well, we've already said that to get the k, you would take the ratio of the y values to the x values. Okay, so let's see if we take our y values and divide them by the x values. Let's see if there is a k, if there is a constant of proportionality. And so what we need to do is take the points that were given to us, which it looks like there are 4 of them, and write their ordered pairs. So here we have the point, if we go right and then up, we would go right 1, up 40, right? Always look at the scale of your graph. It's 1, 1, 40. Of course, we always write ordered pairs in parentheses, right? So 1, 40. This point is, if I go right, how far? Well, it's between 1 and 2. What point is between 1 and 2? That would be 1.5, right? Or 1 and 1/2. So I go right 1.5 and I go up. Well, what's this value? It's between 40 and 80. What number would be halfway between 40 and 80? Well, that would be 60, right? So it's 1.5, 60. 1.5, 60. That describes this point. All right, this point is at, I go right 3 and up to 120. So 3, comma, 120 would describe that point. And finally, this point right here, I go right 4 and up 160. So 4, comma, 160. All right, now what I have just done is write the ordered pairs for the points that were given to me on the graph. And what these ordered pairs are telling me are x, y values. That's what an ordered pair is. Of course, x value comes first, and then the y value, right? X before y, just like in the alphabet. And so what I need to do is take the y values and divide them by the x values to get the ratio. I need to see, are these ratios all equivalent? So first I have 40 over 1. 40 over 1, well, that is 40. 60 over 1.5. 60 over 1.5. If I do my long division correctly, I would also see that that is equal to 40. 120 over 3. 120 over 3 is equal to 40. And 160 over 4. 160 over 4 is also equal to 40. And so what I am seeing here is that yes, there is a k. There is a constant rate of change. And the k is equal to 40. The k is equal to 40. So now I have my two criteria met. I have a k, a constant rate of change, which in this example is 40, and I have the line, the straight line passing through the origin. And if those two criteria are met, if there is a constant rate of change, a constant of proportionality, and the line passes through the origin, then yes, the graph, the relationship is proportional. And so we can write that proportional relationship in the form y equals kx, where k is the constant of proportionality. We found that k is 40, so I can take 40 and plug it into this equation. And so the equation to represent this graph would be y equals 40x. Y equals 40x would represent this proportional relationship.